So today I'll tell you a little bit about electrolytes, and electrolytes are anything that conducts electricity. And remember, we are talking about aqueous solution, so which means everything is to be dissolved in water. So anything that is dissolved in water can or cannot conduct electricity. So what can conduct electricity are ions. So which means anything that is an ionic compound will be able to conduct electricity. So our purpose today is to find out what's an electrolyte, what is not an electrolyte. So these are the chemicals we will be working with. So I have 1 molar hydrochloric acid, 1 molar acetic acid, distilled water, 1 molar sodium hydroxide, 1 molar glucose, and we will also test tap water and see if there are any electrolytes in tap water. So the contraption you need for this is something like this, where you have a bulb with the electrodes in there, and the electrodes will then be dipped in each of the solutions, and then you can see how the light lights up. So here's what I would like you to do in your notebook as you're watching all of this, is write all these chemicals down. So take 10 seconds, write all of these down, and try to predict, okay, if this will be a strong electrolyte or a weak electrolyte, strong or weak or non, whatever it is. So write for each of these. So you can pause the video if you want, and then try to write those things down, and then see if your prediction came right or not. Okay, so HCl, acetic acid, water, sodium hydroxide, glucose, and water. And glucose, by the way, is C6H12O6. Okay, that's the formula for that, and you know water is H2O. Okay, so both of these are H2O. Okay, so now we'll do this, and just to give you a little disclaimer, I'll be washing the electrodes in the middle, so don't wonder about what am I doing here. Okay, so I'm not cheating you. I actually want to keep it as simple as possible and as straightforward. So first of all, you will also note that I have the same concentration of things, okay, because if we change concentrations, so you will change the number of ions in there. So you don't want to change the concentration, so you want to keep the same. So it's all 1 molar, so that way same number of ions, okay, in there. So now I'm going to start to show you how this works. So the first one we'll do is, or maybe I should just wash my electrodes first, just to make sure everything is nice and clean. So this is just distilled water. And now remember, you already have written down whether it should be a strong electrolyte or a weak electrolyte. So go ahead and see what you feel, okay, with this one. Give it a rating 1 through 10, okay, what it might be. And I know you have nothing to compare it with right now, but you will. So the first one was again HCl, or hydrochloric acid. So I'm going to wash this now. No contamination, we're good chemists. And then now I will take acetic acid, okay, which is considered to be a weak acid. So rate this with HCl. Again, go from 1 through 10 and see how you feel. And I will repeat this again later, okay, so in case you missed anything, or you can just rewind the video and you can see it again. And I will do it again quickly at the end. So now what I have is distilled water, and this is the moment of truth where we find out if our distilled water is any good or not, because technically speaking, that's what it should be. Okay, the distilled water should not conduct any electricity, because technically it's just pure H2O. So it shouldn't conduct anything at all. All right, so that's a good sign. Okay, so I don't need to wash this again because it was distilled water. And now I'm going to take 1 molar sodium hydroxide. So hopefully your prediction will come correct for this one. So be ready. Okay, again, scale 1 through 10, or 0 to 10, whatever you wish. So now I have to wash this. And now I have the 1 molar glucose. I hope you got that. Was it 7 or 8? I don't know. You guys decide. Okay. And then washing it one last time, because we have tap water to figure out. Now tap water is the one that's coming from the city. So technically they clean it up, okay, for most part. So you can drink this water, you cook with this water. And so now we'll find out if there are any ions in there or not. So I hope you can see the light. And I don't mean that in any other way but the light. Okay. All right. So in case you want to see this again, let me do this quickly once more. So we have HCl. Yeah, after tap water, that is pretty something. Okay. And then acetic acid. So hope you got your comparison, because I'll stop there. The rest of them were pretty okay. So hopefully you got a good idea, okay, of what electrolytes are like, okay, and hopefully you all managed to come up with the fact that HCl is going to be a strong electrolyte. This is a weak electrolyte. It wasn't as strong as HCl, so the light was much brighter with HCl, and then you have acetic acid, which was weak. The still water is supposed to be a non-electrolyte, and that's what pure water is like. Sodium hydroxide is an ionic compound, sodium and then hydroxide in there, so this was a pretty good electrolyte. And then glucose here, which is C6H12O6, again this is a covalent compound, so it's not supposed to be ionic, so this should be non-electrolyte. Tap water, generally we like it to be pure, but it can't be pure because we have to put some ions in it, sometimes like chloride ions, because chlorine is added to disinfect the water, and so therefore you end up having chloride ions in there. So sometimes it turns out to be, as we say, a weak electrolyte. Okay, so this is how we can test if you have electrolytes or not in any kind of a solution. Okay, so you can make this at home also if you want. You just need 2 electrodes and a light bulb, and you can check any water in there. Okay, so that was it.